What's up guys? Let's start our video today with a demo. This is a demo that you're basically inserting or sending a shop drawing elevation section to this Telegram chatbot, and basically you can extract all the information like for each panel. And a little bit about this drawing is the elevation section for a facade of a building, and then it's comprised of a variety of different sizes of panels. And after these panels dimensions are extracted, then these are being sent to fabricator for cutting. And this process is being automated right now, and you can see here the panel ID, panel group, width, height, and then the converted width and height and area of each panel is being calculated automatically just in a matter of seconds, as you just witnessed. See, here, for example, see this one is like 2 feet 8 inches. That's like more architectural standard or engineering drawings detailing standards that in feet and inches. And there's a human factor is also involved, like converting those feet in inches and inputting that into an Excel sheet. So that's also time consuming. So 2 feet 8 inches, 32 inches, and 8 feet 0 inches, 96. So those are the heights and width for each panel, and there are like different rows of panel, how to get all those rows, and how to teach this AI model to where to look in your drawings and what is important and what is not important, which one to ignore. And this AI model or workflow is just designed for this specific type of shop drawings per request of the channel's viewers. And this is very time-saving process or workflow. So for example, every row, if it takes you like around 2 minutes, like let's say if you have a new engineer and it will take like 2 minutes to extract the information, look for that information into the drawings and input it manually here in these cells, and then convert one of them and then multiply it by the areas. So let's say roughly around 2 minutes each row, and you have 22 panels or 22 rows. So that's 44 minutes right there. And 44 minutes, and matter of like if you reduce that into like few seconds, you saved a lot of time. So that's basically the video of today, and I will discuss how I created this workflow, and you can copy this, or the whole process is going to be similar if it's not the same for your purpose or your needs. So you can do other applications on this, like rebar calculations or rebar quantity takeoff and so on. Hello everyone. Today I'm going to introduce you what the time-consuming problems that we're facing in the engineering world, and that is mainly in the shop drawings to fabrication process. So this is a shop drawing sample, and you see a lot of dimensions for a lot of panels. So this specific one is used in the building industry, and it's a facade of a building. So they're comprised of a variety of panels, different heights, different widths, and a lot of dimensions, and a lot of human tasks are involved as well. And let me paint the picture for you. Have you ever spent hours and hours, or sometimes an entire afternoon, manually pulling these dimensions off of these kind of shop drawings and typing them into an Excel sheet like this? You can see here the widths and the heights and the panel numbers, rows, and everything. So today I'm going to show to you how to replace that tedious 2 hours or like few hours of work into a matter of seconds using a single N8N workflow that does it all for you in a CSV format to email automatically in a matter of seconds. So here, for example, the current process is an operator, a machine operator, that they're cutting these panels, or an engineer in the shop. So they're trying to extract information from these engineering and technical drawings to the table or an Excel sheet, or just kind of a little database that they're creating for every project. So for example, here, 818 inch, so around 9 inch, right? So if it's above that full integer, then that's the next, is the round up, 9 inches. And that's the width of the first panel. That you put it right there in the width. So then there's the panel. the first row of the panel. And then the height of the panel is like that. It's 2 feet, 138 inches, and so basically 26. So that's the height for all these first row panels. And 3758, so that's the next panel, is 44 inches. And then there's the panel. The next one is 33 inches, and the next one is 11 inches, and so on. So here you can see that the engineering format or architectural format is like the feet in inches, and they have fractions as well. So those are pretty commonly known and standardized in the engineering drawings or plans or detailing. So here, if you want to get the quantity takeoff based on all these, there's a little conversion factor is also happening. Like you have to change the feet into inches, the fractions into decimals, and then sum both of them for every single one of them. So then you can create just one measurement units. So everything collectively, so it takes a lot of time. So today I basically talk about this. Our video is going to be about this, how to automate this process and remove all these tedious, repetitive, time-consuming process by humans, and give it to the AI. And we're going to use the N8N workflow for this. And let me explain all the details about this process. This is technically the workflow in N8N that I created, and it's pretty simple. It doesn't have like a lot of complications or complicated stuff, but the main heart of this is about this node, OCR, and parsing, so that later on I can talk about this. So let's start from the trigger. The trigger is whatever you can choose. Like I choose here the Telegram application, and it's readily available and compatible with mobile applications as well. And you can just download it from the iOS App Store or from the Google Play, and then you can use it easily. So even if you're on site or you don't have your computer station, so then you can use the Telegram application. So there are a lot of other triggers that whatever you prefer, for example, WhatsApp application or like any other webhooks that you can use, or Gmail or Google Drive. Like as soon as you're uploading an image in the Google Drive, then it gets activated. So that's your preference. And the second node is basically the OCR and parsing, which is basically an OpenAI model, is the image recognition and dimension extraction. This is basically the heart of this workflow and how to tell the model and to extract all the information that we need, because these drawings, they're full, they're packed with all these information, technical information, like site locations, like all these different aspects of this project, right? And how to make these models to focus on the areas that you want. So that is basically the art of this workflow. Then the next one, after you extracted all the information using the ChatGPT 4.0 latest model API, and later on I'll also talk about that, like which model is the best to use. This is a little bit more expensive compared to the 4.0 mini, and 4.0 mini high is a pretty quick API. It just doesn't cost a lot. This one is cost a lot, a little bit more than that. So then from there, once you got all the dimension extracted, then you send it to this other model. It's also an OpenAI model, and it's a data conversion agent. So once you got that, because I tried both in one node, and then I found out that the problem is that the model gets laggy, and it does not follow the instructions correctly. So this is why I said, okay, that the content is okay, and then you send it to another model. And here, that model is the ChatGPT 4.0 mini model. So I'm using the two different models from OpenAI and two different APIs to process this data. And after you process that data, the data conversion is over, and then you can send it over to back to the user, which the Telegram user. So that's a feedback. Okay, I converted all the data and extracted all the information from it, and here it is. And then also you can send it to an email address. So this email address could be the manufacturer or the fabricator or person who cuts all these panels. And after that, we talked about it earlier in the introduction about the current operation without automation. It's pretty tedious, it's time consuming. And I have to mention that by no means this is the perfect way to do it. So there should be like a lot of other solutions, but this one is the one that for me it was easier to do, and using whatever I have, like minimum resources, maximum usage. So this is basically what I came up with. And if you guys have any other comments or feedbacks on this and how to enhance this kind of operations and processes, please let's see and discuss in the comments. And I'll be really happy or glad to continue this and enhance these types of workflows because they have like real life impacts on the engineer's day-to-day work. So, all right, then this is all about the nodes, and let's move on to each and single one of these nodes. The first node is the Telegram trigger. So let's click on it, and this is the Telegram trigger node. And you can see here that you should have a Telegram bot. So previously I created all these credentials in here. So this is the shop drawing rater or reader. It's AI reader. So basically I created this bot and it's available in the shop drawings. I mean in the Telegram as well. So you can go ahead and create one of your own. And how to create a bot, a chat bot in the Telegram. I mentioned it previously in my previous videos, how to create one of those. So that's already there. And then the trigger should be with any kind of messaging. And mainly this message is supposed to be like an image message. So it won't interact with you with any text messages. So it's supposed to be an image. So this is the download image. So you're turning that on. So you can add a field and that will be the image or files. So turn that on, and then in the settings, so you don't have to do anything else. So just keep it as is by default. That is the shop drawing JPEG. So you're sending a JPEG. All right, so now we're setting up the second node, which is the OCR and parsing. It's also an OpenAI model. And prior to do that, and I have to mention how to prepare the JPEG pictures or images that you're sending it to the Telegram first. So as you saw in the introduction of the video as well, and here this is like a sample of the JPEG. So you're basically taking a snapshot of the elevations. So if you have like multiple of these in one sheet, then you need to separate them and make them as one. Because if there are too many, then it gets a little bit confusing. And this was at least like my method. I know it's a little bit more time consuming and like a little human interaction is involved in here. So we can enhance in the next versions of these completely automated to feed the whole PDF file into the Telegram app, for example, and then wait for like, let's say 10 minutes or 15 minutes or 20 minutes, and it will spit it out for you like hundreds of these panels populated into those panels. Then the QC problem or the quality control problem will be a little bit problematic. What if the sizes of all these panels are not accurate enough? So in here, you can check one by one, and you can do like a minimal supervision at the end of each data extraction. Then you can see it if it's correct or not. All right, so this is a cropped version JPEG for each elevation. So we have 3 rows of panels here, dimensions here at the top, and 3 rows of vertical dimensions here on the left side. So it's here 2 feet. Let me pull it up a little bit. So here 2 feet 138 inches, 9 feet 78 inches, and 3 feet 21.5 inches. So here the top row, the first dimension corresponds with the left column and the bottom row. So basically what I meant by that, if you're focusing on this small little panel at the bottom left, so the width is 818 inches and the height is 2 feet 138 inches. So, and then going further, the second row 1718 inch, and then the height for that second row is 978 inches. So you see there's a pattern, right? And then the third row from the top, which is SPFF1, I don't know what that stands for. Probably that's the designation for panels. And 1518C, like the dimension line corresponds with these panels at the top. I mean this panel at the top here you can see, and the height of that panel is 32.5. So you can see the correlations, right? So the very top corresponds with the bottom dimension. The second from the top corresponds the second from the bottom here on the vertical dimensions, and the third one here on the left side as well. So that is the main pattern or logic that we found in these type of drawings. The rest is pretty easy. Now you have to explain whatever you see here to the model. And let's go to the model here. And the model here, like the second one, is the OpenAI model. So if you have an OpenAI account for the APIs, of course, not the ChatGPT, but the OpenAI account for APIs to use. So you create a credentials. If you don't know how to do it, of course, you can do and check out the documentations here or my previous videos and let's see, there are like a ton of videos also available on YouTube that you can see how to connect the OpenAI with the N8N. And resources is supposed to be image because you're sending a JPEG, and then analyze image, which should be the operation, or not generate, not custom API call, just analyze my image. And the model that I use, as I mentioned in the introduction, is the ChatGPT 4.0 latest. So this is a little bit more pricier compared to the mini version. The 4.0 mini is the cheapest one. So this one had a good outcome. But here, let me talk about this prompt. This prompt, as you can see here, that's pretty long prompt. So I spend a lot of time on this, how to pinpoint exactly what you need from these models. It is very simple to for us humans to know or explain it to somebody else or another human. But if you want to explain it to the machine, every single step it needs to be followed. And that's how I tackled this challenge. First of all, I'm asking him, what are you? What is your role? You're an AI expert in reading structural engineering drawings and extracting panel dimensions. So you give him a role. So it already knows, okay, I'm a structural engineer now. Now I'm an AI expert reading all these drawings. So you're giving them a signal because the machines, they're starting from the top or from the beginning and line by line interprets what exactly you mean. Then what are your tasks? The first step is identify panel groups. So panel groups are basically those SPFF 3, 2, 1. These are all panel groups, right, in different panel rows. So the second step for you, what to do, it's extract with values. So the with values are basically in here, like 8, 3, 7, 8, 2, 8, 5, 8 inch, and 10, and so on. So what I did, basically, it's the OCR or optical character recognition algorithms, usually they find the text blocks or that text with the bounding box around them. So they have a bounding box around 3 feet 758 inches. So if I told the model, if the width of that bounding box is greater than the height of that box, then that text or that dimension is basically a width. If the width of that bounding box is less than the height of that bounding box, then that is basically the height of the panel. If you found a text like that, that is the height. So I gave him that one logic because the height is 90-degree rotated, right? So the 90-degree rotated, almost all of them, like, you know, the height is less, the height is more than the width of that bounding box that it found. So that was the logic, and I also gave him that logic in here, and then gave him some examples as well. So for each panel group, scan the corresponding horizontal dimension, chain from the left to the right, recovery and individual dimension exactly as written. So I even gave him like the feet in inches. What are the feet in inches? And what are these different examples? So there are some different examples, the 3 feet 7 inches and the fractions, the decimals, and all those are very important to give him some examples. Some spaces, like these little spaces, are very important too, because sometimes like 85/8 or 8 space 5/8. So these are little details that you have to take care of it one by one. So each width value will become a separate panel in your final table. So, okay, the third step is basically the height of the panels. The height, since it's rotated, it's pretty critical. So I gave him like a signal. This is very important. Pay a lot of attention to it, because I had a lot of problems figuring this thing out and telling the model how to find it. So I give him all the information and the one by one how to do it and where to find it. So those are all the information that I can put this in the description, so you can copy directly this one and use it for your own. So critical mapping instructions. So in the first bottommost dimension, so the value corresponds to the height of the topmost panel group 1. So I'm giving them all the explanation that I showed it to earlier, so that I'm just like reading it and spelling every single thing for them. And these vertical dimensions may appear as the small values, like 2 feet, 0.78 inches, and are typically found stacked vertically. So these are all the information that I asked the model to find out. So furthermore, the vertical dimensions, I gave him the visualization aid. So if the drawing has 3 panel group labeled top to bottom, is SPF of 3, 2, 1, the bottom most height dimension applies to SPFF 3. So giving him more and more content and more explanations. So step 4, double check height assignments. And the height assignments, so verify you've correctly identified the leftmost vertical dimension chain and all those with the examples. So the step 5 is build the panel table. So now once you extracted all the information and you figured it out, which one is a height, which one is a width, then correlate each one with each other, like the height with width of each panel, then give me a table. So this is the panel ID sequential integer is starting at 1, and then the group label is SPFF3, for example. So that's an example. And then width and height. So give me the output like this. Output format, it's supposed to be a CSV table without additional commentary. So sometimes these models, they'll give you more explanations, but I say like do not give me additional commentary, because if you add more, then it will take out of that 4,000 limit that you mentioned in here. So then the example output is supposed to be like this: panel 1, 2, 3, the groups 3, 2, and 1, and the heights and the width, give me that. Now process the attached image and return the completed table. So that's the rough idea of all like this custom prompt. After you did that, then you choose this 4,000 based on my job or this specific one. You can increase or decrease that, and it also costs you a little bit if you increase them, because that will take the model longer and it will provide you a longer response. All right, after you did that, then you send that information to another model, which is the cheapest model, is a ChatGPT 4o mini, is cheaper compared to the other one, and give him like, what is your task? So that's basically the task to convert all these inputs into the same measurement units. So this is basically the input. Your input table is the content. That's, if you go to the JSON or the schema, so this is the content in the previous node. So I haven't executed the previous node, so let me deactivate this and the test workflow and do forward this to the ShopRater. So I guess that gets back to here. So I'm sending this to ShopRater, send it here, then gets activated. All right, so it goes to the OCR and parsing, so of the image. So it will take a while, and it sends like, pretty quickly, and then also sends an email. Okay, so once you did that, now everything gets updated. So if you go here, this is the input, this is the output. So the input is basically the content. Content in here is this. You can drag it and drop it in here. So that's basically the content. So Yeah, this section is all content. So you can grab this content and drop it in here. Once you did that, your task is to create a table from the content below with the column names below. So this the content is input. The column names, I give them like panel ID, panel group with height already, and width in inches, height in inches, and area in inch square. Then I asked them like, the explanation, the same as before, like how to come up with all these conversions. So this is not a calculator. It's not like in a mathematical model. So it's a language model. So give him all these, although it has the capabilities of a lot of calculations, the recent models from OpenAI, but still, like, explain every single thing with examples and for them to know it. So I give him all the examples. Okay, the first line, how it should look like, and give him like all these variety of explanations and examples, and finally what the output should be and what exactly I want. And the role is a user, so keep everything else as a default, and then that is your final results. And if you get back to the here to the Telegram, so it also updates the same results to you, and it also sends it in an email. So yeah, it updates the user and also sends it to an email. That's pretty much the whole workflow. And I can copy this in the JSON format as well in the description. You can find it from there. Now let's test the whole system with Claude and then with Gemini from Google. Claude is from Anthropic, so those are different type of models. So for in order to do that, let me copy the exact same prompt that I used in here for OpenAI model, and I'm going to use the same exact prompt for the Gemini, I mean the Claude for the first time. Like let's say paste it here. So I'm just like doing exactly that, and then adding, uploading a file to it. So let me drag and drop it if it works here. So let me drag and drop this. Yep, it does work. So let me try this. It's a 3.7 sonnet, and let's see the outcomes. So it will explain to me like, what will be the outcome. And here is pretty cool, like, the way that it extracts the information. So see, it extracted a little bit more information, like 2 more panels for me, because in the ChatGPT, I mean the OpenAI model, it gave me 22 panels, but here it gave me 24 panels, and I guess I have to increase that 4,000 limit. So that might be one of the solutions or kind of troubleshooting. So here 2 feet 1 inch, and then 3 feet 2 inch. So let me double check if they accurately got the information. So one of the problems that they usually miss is the very first one, the inch, the 8 and 1/2. This one here, it's 8/1/8 of an inch, but here it found here you can see 8/1/2. So those fractions are a little bit difficult for these models to pick. And here it says 2 feet 1 inches. On the other hand, like the model from OpenAI, it gave me 1/2, and the height was 3, 2.5, and then let me double check. Okay, so 3, 2.5. It was the height for that, but it found it couldn't. The Claude one couldn't find the half fraction. So Claude has like this problems with fractions, and if it detect the fraction, it will detect more accurately compared to the OpenAI. But if it doesn't, then it will miss it completely. It will drop the fractions. And since we saw in the problem statement or the Excel sheets, so if it's more than that integer, that number, then that's the full inch. So that's we're not supposed to like think a lot about the fractions of an inch. So it's in the fabrication, it's construction. So 1 inch tolerance is acceptable. And here you can see all these different responses, but I think like Claude, it gives a little bit more organized, and the system is comma separated value, as exactly I asked them, like, what your output should be is a CSV format, is a comma separated. So sometimes in the Google, I mean the Open AI, it does not provide the comma separated. It provides the Markdown or HTML format for me. So that's something that to be noted. Let's try Gemini right now. So the same thing that we did previously for the other Claude function. So for example, here I can go ahead and copy exactly the same thing and go to my Gemini and paste it. And I'm also trying to add this image in here. So as a drag and drop, and then let's see what it comes up with. So I'm asking it. So this is the previous response. So just neglect that one, and it's still working. It's building a new CSV for me. All right, so this is a new image. You can see here the SPIFF 3.818 of an inch. So here you can see the 1/8 of an inch was detected by Gemini, and it's pretty cool. So Gemini also gave me 22 panels. In the 22 panels, the same thing as OpenAI gave me 22 panels. So only Anthropic or Claude gave me 24 panels. Then so surprisingly, that more is not always good. And if you see here in this picture or image, if you count all of them, they are actually 22 panels. So the two more panels, because it's detected, that Claude detected like these dimensions as well, like these other ones that they're not completely according to the instructions, that it was like on the left side and the top side. So probably it detected like one of these 13 feet or 1/8 feet. So this is why, like, comparing all these different models are very important for your purpose or whatever you wanted to test them. And here with the fractions, Google Gemini is pretty accurate with fractions, and 7838 is very accurate compared to the other models like this one. It didn't even recognize. Oh, I guess that's the wrong one. Oops. The Claude that we found here. So you cannot see like a lot of in the height. It could not find any fractions for us. And those are like some of the problems that you might want to consider when you're dealing with these kind of problems. So the accuracy so far from OpenAI and Gemini is pretty high compared to Claude. And within OpenAI, there is another model that is only available in the ChatGPT format that it can even more accurately. This is the Orion. Orion, I believe. Here is the ChatGPT. It's not like the OpenAI APIs. So let's I try one of these other ones that they're very like O3. So let's try the O3 first and copy or I mean paste the same prompt and then drag and drop, and let's see what it comes up with. So O3 is the highly advanced model. So here it shows you all the steps that it can take, and see these are all the Python coding that it just shows it to you how it comes up with all these reasoning and answers for you. So every single step, so see here, it just focuses on the top row. Here, it's the top row in all dimensions. It tries to find out analyzing image. So zooms it in and then creates like, the second row, the third row. So these are the examples for the SPFF or the panel, the panel groups. Here, more, you can see all the analysis in depth and all the pixels. So the ones that they cannot read, it just zooms it in and it creates it, like all those fractions. It's pretty interesting, like the way that O3 works. And O3 is totally different compared to all these other models. It's a little bit time consuming, but it's very detailed. And the good thing about the O3 is that it actually tells you what it does every step of the time. And it can basically reads all these images based on these instructions, and we can wait for it till it gives us the results. I guess it has a problem at that 1/8 of an inch at the top because it's pixelated and the JPEG is not that clear. So this is why it's having problems. So examining width values and dimensions so over and over again. So it's making sure like every inch or every pixel of the image, so it's analyzing it. This is pretty amazing. Like if you were to code this in Python, it will be a tremendous amount of efforts to do that. But here it just it does it for us based on just plain English explanations. So that's the beauty of the NLP and the recent models. And I found out that O3 is pretty detailed. And if you can go ahead in the top, that drop down arrow, you can see the little underneath each model. So say GPT-4o is great for most tasks, which we used in our example earlier throughout this video. O3 uses advanced reasoning. So if you're dealing with a lot of mathematical issues, engineering issues, problems, then I guess this is the best for you. O4 Mini is the fastest advanced reasoning. O4 Mini High is the great, this is kind of faster, great at coding and visual reasoning. And 4.5 is the research-oriented, actually no, research preview, and good for writing and exploring ideas. It's more like, you know, language-based. And 4.0 Mini is faster for everyday tasks. So these are like little explanations for whatever purposes that you have. So O3 is advanced reasoning. Let's see what it comes up with. So it's still working, and you can see all the working. You can maximize the work as well, what it did so far from the beginning. It analyzed the image. So this is the full image, and analyze the top portion of the image, zoomed in, a little bit more zoomed in, different parts of the top 2 rows or 3 rows. So it's trying to focusing it. These are like a very cool explanations of each step of the way, like what it does. So here, more steps, what it did. So it zoomed in all the way like that 8/1/8 of an inch because probably couldn't read it at the beginning. And between each panel, there's a 3/8 of an inch gap. So that gap is for construction purposes and fastening all these panels to the frame. So I believe that 3/8 of an inch is also creating some problems to be detected. So moving on, it just like, you know, creates like, you know, some extractions here. Let me go ahead and see if it came up with the, okay, it's still working. So it still hasn't come up with the final answer. So let's go ahead and check one of those extracted dimensions. Okay, SPFF2 widths listed. The dimensions are. So let's go ahead and see SPFF2, the dimensions. So let's say SPFF 1738 inches. So 1738 of an inch is 1/8 of an inch. So instead of 1, it actually got 3/8. 1058 is correct. And what else? 2858 is correct. The next one is 3758 and 3758. 1058 inch is the next one, and 1918 is the next one, 1938. So two small little between 1 and 3, because you saw how zoomed in was that, like that little piece to detect it. So there was one is like all the way zoomed in. So this is why, like, you know, getting a clear picture or image is also very important, not pixelated image. So it's still working. I'm thinking of relying on previously extracted heights and larger image I checked earlier. Okay, so it's tried to find out like what exactly that is. Is 7/8 or see 1/4? It found the 1/4 because you see that's very pixelated. 918. So see 978. It finds it 978 and then kind of correlates it back. So it's very detailed. It's very detailed. But as you can see here, we're spending like, you know, minutes and on this. So let's see what the final answer will be. I guess this is still searching and finding, trying to figure out what that fraction is. So it's zoomed in all the way because it's not sure what exactly that is. So it just refers to other parts of the drawings and see if that is similar, like even like the rotated version or rotated text as well. So it tries like different methods to come up with more accurate results. So I believe I'm it just like, goes furthermore and enhances it. So I guess it's creating the CSV format right now and then plotting it at the end. So is it still working? We don't want to stop it and see what the final outcome is going to be. But yeah, it is pretty time consuming. This model is like around 3 to 4 minutes based on all the instructions in one image, but it's still much, much better than 44 minutes that we were anticipating or estimating. But here you can see that it's pretty accurate, very accurate. 22 exact models, exact panels, and all the fractions are 3/8, 5/8, 1/2. So everything is pretty accurate. So O3 is so far the best OpenAI model. So it correctly